Hello student, today we will discuss three questions from chapter 8, and then we will continue with the force and laws of motion. So question number 8 to 10 we will discuss. The speed time graph for a car is shown in this figure. How far does the car travel in the first 4 seconds? Shed the area on the graph that represents the distance traveled by the car during the period. Then, which part of the graph represents uniform motion of car? So we have two objects in this question, and the answer is like this: 0 to 4. So 0 to 4 we can make one triangle here. We can say this is one triangle. And we know speed time graph or distance time graph. Area under speed time graph gives us the displacement. So the area of this triangle, base into height. The base will be 4 and height is up to 6. So 1 upon 2, 4 into 6, that is 12. So the distance covered will be 12 meter. And the B part that represent the uniform motion part. So it will be from 5 second to 9 second. Between 5 second to 9 second, object or 4 second near about, object moves with uniform speed. This is the answer of the B part. Now question number 9. State which of the following situations are possible and give an example for each of this. An object with constant acceleration but with zero velocity. Now this is very simple. Constant acceleration but zero velocity. So in answer of this question is what? When you throw an object at highest point of its motion, the velocity will be 0. But the acceleration due to gravity acts in downward direction. So at highest point of its motion, when a stone is thrown upward, at highest point of its motion, velocity will be 0 and acceleration is constant, and that is g, and that will be equal to 9.8 meter per second square. Its direction is downward. Velocity is 0, but acceleration is not 0. Then, now we have B part. Which part? B part. This is an object moving in a certain direction with an acceleration in perpendicular direction. Acceleration in perpendicular direction. So two examples. One we have already discussed, that in circular motion velocity is here and acceleration is here. Also when you throw an object horizontal direction like this, so velocity is here but the acceleration always in downward direction. See, when an object is thrown forward direction, during its motion, the horizontal direction, the acceleration due to gravity acts in this direction and velocity is this. So this is an example. This is one example, velocity and acceleration perpendicular. Apart from that, one more example. In circular motion, velocity this side, acceleration this side. Okay, so this is another example. Like this you can search many conditions These are the two conditions. Like this, you can search many conditions in which velocity and acceleration are perpendicular to each other. Okay. Now we have one more question left. This is: an artificial satellite is moving in a circular orbit of radius 42,000 km. Calculate its speed. It takes 24 hours to complete around the Earth. Satellite is moving like this around the Earth. This is Earth. Satellite is moving. So you can use V equal to 2 pi r upon t. Now we have to calculate t is given, 2 is given, 2 pi r. Radius also given 42,250. So put the value of radius here, pi 3.14 time 24 hours. So it will be like this. 2 pi r distance will be 2 pi r. This is 2 pi r. 2 pi r. So it will be 2,65,330 and divided by 24 hours. So it will become 11,055 km per hour, or you can divide with the hour into second 3,600, because in 1 hour 3,600 second. So it will be 3.07 km per second. Both the answers are correct. So like this you solve the remaining questions. All questions we have solved, no remaining questions. We will conduct one test based on this in next. I will tell you that you complete the notes of this topic, and now we will learn little bit about the force and motion. Okay, little bit about the force and motion. We know motion is discussed in previous chapter. In the previous chapter we described the motion of an object along a straight line in terms of position, velocity, acceleration. We saw that such a motion can be uniform, non-uniform. We have not yet discovered the cause of motion, why motion takes place, and that is called the dynamics. Last chapter was kinematics. 2 chapters were kinematics. Now we will discuss the dynamics. Dynamics is a branch of physics, mechanics, in which we discuss the cause of motion. This is very important. Why object is moving? In this chapter, we will find the answer of this question. For many centuries, the problem of motion and its cause had puzzled the scientist and philosopher. A ball on the ground, when given a small hit, does not move forever. Such observation suggests that rest is the natural state of an object. This remained the belief until Galileo Galilei, Isaac Newton developed entirely new approach to understanding. Before Galileo Galilei and Newton 1600 century, Galileo Galilei 1400. Before that too, nobody was aware about the motion and cause of motion. It was Galileo Galilei who has put forward the theory of motion, cause of motion, and then formulated by Newton. In our daily life, we know that pushing, this you have learned in class 8th class. In fact, no one has seen or tested or felt a force. Object is moving. Suppose an object is moving. So we are applying a force. But why object is moving? Force is applied. So what is that force? In our everyday life, we observe the motion. Some effort is required to put a stationary object into motion. we ordinarily experience muscular force and say that when we must push or hit or pull on an object to change its state of motion. Pushing, hitting, and pulling of objects are all ways of bringing the objects in motion. We can bring them in motion. They move because we make a force act on them. Due to force, the object moves. See, here they are applying force. So when they are pushing, pulling, hitting, here we are pulling, pushing, hitting. These are the example. And due to force, we can change the shape and size. From our studies in earlier classes, if we apply force, we can change the shape, we can change the velocity, we can change, and when we can change the velocity due to force, the object can move faster. Due to force, the object can move slower. Okay, and sometimes this boy, suppose this is, we are pressing, so when we apply force, you can change the size. When you are applying force, spring, if you pull this side, you can change the shape. So all these things, force is very important physical quantity. So there are two types of forces. One is balanced force and one is unbalanced force. Due to balanced force, in X and Y, two strings X and Y are tied to the two opposite end of a block, this block. If we apply force by pulling the spring X, the block will move in X direction. Similarly, if we pull, X direction is this side, X direction means right side. And similarly, if we pull the string with Y, so it will move in this side. But if both the forces are equal, then object will not move. That is only called the balanced force. Due to balanced force, there will be no motion. Such forces are called balanced forces and do not change the state of rest or motion. And there are many cases in which if one force is more than other force, then it is called unbalanced force. If this force is more, so object will move this side, so then it is called unbalanced force. So we will discuss all these things, balanced and unbalanced force, in next period. Till that time, you think about the cause, what is cause of motion, what Galileo Galilei did and Newton did, and how the concept of force developed. Thank you.